Hi everybody. In this tutorial we are going to look at how to use SPSS to compare means, and more specifically how to use SPSS to conduct both an independent and a dependent samples t-test. So just as a general kind of starting point, remember that whenever we have two groups of participants and we want to compare their means on a dependent variable, we would need to use a t-test. And we would use an independent t-test when the two groups are totally separate and independent of each other. And we would use a dependent samples t-test when the samples are related to each other. A commonly used situation for a dependent samples t-test would be when you have a pre- and post-test from the same group of participants. Anyway, before we get into the actual calculations, let's just quickly orient ourselves to the data set. If you've been watching these videos from the beginning, you should be familiar with this one. It's the same exact data set we used in tutorial number 2 and tutorial number 3. So just as a quick reminder, we've got 43 participants, as you can see from the data view. In the variable view, we have 8 variables: participant number, sex and age of our participants, and then our 5 personality variables. So without further ado, let's get into how we go about comparing means. Before we actually run a statistical test, we can use SPSS to just compare the means between the two groups so we can visually see if there is a difference worth following up with a statistical test. So if we go to Analyze and then to Compare Means and then over to Means, we get this box here, and SPSS is asking us for our dependent list and our independent list. So let's say, for instance, we want to see if there is a difference in extroversion between males and females. In this case, sex would be our independent variable. It's not a true independent variable because it's obviously not something that we manipulated, but it is essentially our independent variable in this sense because it's the variable that we want to see. It's our grouping variable where we want to see if there's differences between our two groups. We would then put extroversion as our dependent in the dependent list box, and we can click OK. And what this is going to show us down here in the report box is the extroversion mean for males and the extroversion mean for females. So we can see that for males the mean is 3.3971. For females it is 3.4652. In total we have a mean of 3.4430. So between males and females, clearly we have pretty similar extroversion means. However, they're not identical. I mean, 3.3971 is not the same as 3.4652. So there is a bit of a difference. We also can see the number of males and females that we have in this data set, as well as the standard deviation for males, for females, and for total. So using the compare means is a pretty good way of getting a sense of what differences there are. Going back to that same spot, so Analyze, Compare Means, and Means, we can actually look at more than just one variable at a time. So I can put in all 5 of my personality variables, click OK, and now I'm going to get not only the mean difference for males and females between, or not only the means for males and females in extroversion, but also for agreeableness, conscientiousness, neuroticism, and openness. So just by looking at it, I can see that, you know, there's not a huge difference in extroversion. There is a larger difference in agreeableness. They're very close in conscientiousness. There is a bit of a difference in neuroticism, and again, they're very close in openness. So this is a good way of just getting a sense, again, of whether or not there are group differences to begin with. But this is not a statistical test. This is really just a descriptive statistical analysis. It's just looking at the means for our two groups in this case. If we wanted to go further and run an independent samples t-test, we'd have to do something a little bit different. And again, an independent samples t-test would be appropriate here if we wanted to compare males and females on one of our personality variables, because they're totally separate groups. The males and the females are obviously not the same person, and their scores are not related to each other in any way. So if we want to run an independent samples t-test, it's very easy to do. We need to go to Analyze, Compare Means, and then we're going to pick Independent Samples t-test. That brings up this box here. SPSS needs a little bit of information. It needs to know what it calls our grouping variable, and this is basically the independent variable, or again the variable that contains our groups. So in this case that would be sex. It also needs to know what variables we're testing. These would be our independent variables. So let's say we want to test for differences in agreeableness this time. We are almost ready to go, but if you notice that little OK box is gray, we can't click it because SPS needs more information. And it needs information on this grouping variable. You can see the question marks. So if we go back to our grouping variable, before we can run the analysis, we have to do what's called define the groups. And basically SPSS just needs to know what are the two groups in that variable, in this case sex, that we're comparing. In other words, what is the number that we used for group 1? What is the number that we used for group 2? Now, if you remember, which you probably don't, but from way back when, I believe males were coded 1 in this data set, females 2. So really, we're basically just comparing the 1s and the 2s. Now, in this case, it's pretty obvious. It seems like an unnecessary step. But you could imagine a situation where you have a variable, let's say age, which we do have, where we have 1s, 2s, 3s, and 4s. A t-test only compares two groups. So if we only wanted to compare, let's say, the 2s to the 4s, here, if we had age as our grouping variable, we would have to enter 2 and 4 to tell SPSS that those are the two groups we want to compare. But in this case, we've only got 1s and 2s. Those are the two groups we're going to compare. So we've entered them. We can click Continue, and then we can click OK. Now, the output that you get for the independent samples t-test can be a bit confusing at first. You have this group statistics section here, which really is not all that useful. It's basically just telling us what, in this case, we already know. The means for males, the means for females, the standard deviation, and then also the sample size. Again, that's what we already looked at, so we can ignore that for now. This here is really your box of output for the independent samples t-test. Now, there's a lot going on here. You have a couple of things. Up front, you have what's called a Levene's test for equality of variances. This is something that's beyond the scope of this class. We're not going to worry about it. Basically, one of the assumptions of the t-test is that the variances between the two groups, or in the two groups, is the same, basically. And so this Levene's test just tests to see if that's true. As long as this significance value, or p-value, is greater than 0.05, which clearly it is here, you do not have to worry about this. And you can assume that the variances are equal, which basically just means that you can use the top row for all these other cells. If the Levene's test was significant, so if that significance value was smaller than 0.05, the best practice would be to use the bottom row, which is an adjustment for having variances that are not equal. Again, that's kind of beyond the scope of this class, but we have to address it because that's the way that SPSS does the output here. So we can use the top row. So other than the Levene's test, we have the t statistic itself. We have the degrees of freedom for the test. We have what's known as the p-value, or the significance value for the test. We have the mean difference, and then we have a couple other pieces of information, something called the standard error of the difference and the confidence interval. Some of this you can look up in your field textbook, what exactly this means. It's not really relevant to the class right now, so we're not going to spend too much time with it. When you get to 520, the next course in the sequence, we'll dive more into kind of the nuts and bolts of statistical significance. For now, the columns that are most relevant to us would be the mean difference. So that's simply how big of a difference is there between males and females. There's the number right there. It is the exact same number you would get if you just subtracted our two group means. This p-value here, and again, SPSS uses the term significance value. Two-tailed, it's a type of test. That is the p-value. If that number there is smaller than 0.05, we would have what we'd consider a significant test. Now in this case, it is very close, 0.058. That being said, it is not smaller than 0.05, right? I mean, 0.058 is larger than 0.05, although it is close. So in this case, we would say this test is not significant. We would say that the difference between males and females is not a significant difference. It is not a statistically reliable difference. It's close, but it is not significant. And in statistics, when we do hypothesis testing, the test is either significant or it is not. We really don't say it's close. So in this case, we would have to say, no, it is not a significant test. So that is how you run a independent samples t-test in SPSS, and that is how you interpret the output. If we have a situation where we have two groups and we want to compare the means, but the groups are not independent, meaning that they are related to each other, we would of course need to use a dependent samples t-test. So let's take a look at that next. If we go back to our data set, and let's look at the data view, we can see that the data that we have, we don't exactly have a pre or post test because it seems like participants were only measured once. In other words, their personality was assessed once. So we don't have the pre and post test, which would be a good situation to use a dependent samples t-test. However, we still have a situation where we could do it here because if you think about it, each of the personality variables is a separate measure from the same exact person. So we could, for instance, just test to see if there's a difference between extroversion and agreeableness in our sample. So independent of whether people are males and females, let's ignore that. Let's look at everybody all at once. Is there a difference between extroversion and agreeableness? In this case, we would use a dependent samples t-test because the extroversion scores and the agreeableness scores, they are not independent of each other because they are, after all, coming from the same person. So, in a sense, we only have one sample that's been measured in two different ways. Their extroversion and their agreeableness was assessed. So this calls for a dependent samples t-test. To do that, we're going to go to Analyze, we're going to go to Compare Means, and we are going to go to Paired Samples t-test. That is the terminology used by SPSS. Paired samples t-test, dependent samples t-test. Those two terms can be used interchangeably. When you get to here, SPSS simply wants to know what is the pair of variables that you're looking at. We want to compare extroversion to agreeableness. We just enter them in. SPSS by default puts them in the same pairing, pair 1. That's all that we need to do. We can click OK, and we are going to get all of this output here. And this is the result of our test. The first box just shows us the overall mean for extroversion, the overall mean for agreeableness. Again, this is looking at males and females together. We can see that we have a 3.44 as compared to 3.77. We can ignore the second box. The third box gives us the results of the test. We see that mean difference. And again, that's just the difference between our extroversion and agreeableness scores. And then over here, we have that p-value, that significance value. In this case, 0.075. That is, again, greater than 0.05. It is close, but it is greater. So that tells us that, once again, we have a non-significant test. So just like in the independent samples t-test, we use the p-value to determine significance.